Now here's a different idea. You know, this notion of letting the programmer deal with it. This idea is popular, and then it goes away, then it comes back, and it goes away. So this is, we're sort of in a going away part of the cycle. But the notion is I have all of these functional units. I have, you know, a couple integer units. I have a floating point multiplier. I have a floating point adder. I have all these guys. What I'm going to do is, instead of building this hairy piece of hardware that takes a simple program and says, okay, you first functional unit, you do this add, and here's another add the second guy can do, so forth and so on. Instead of having the hardware figure that out, I'm just going to think of this as a giant instruction where I'm going to explicitly say, well, here's what the first integer unit does. And you can see that sort of looks like a beta instruction. Opcode RC, RA, RB. Here's the opcode and the 3 registers for the second integer unit, and then the floating point operations, and the what I should be doing in memory, a load or a store. So I'm just going to let you, it's like a giant piano, and you can play whatever set of chords you want in order to keep all the functional units busy. And then we'll let the compiler worry about how to take a standard program and do a good job of filling up all of these very long instruction words. So it turns out that for some types of code this works really well, but mostly it's hard to take a program, a standard C program or something, and compile for this, because the C programmer hasn't made it clear which things can be done in parallel well enough for the compiler to say, wow, I can really pack these in. Sometimes it works out well, but sometimes it doesn't. But VLIW is sort of a neat idea. What it does, it's always good to, as an architect, to say, look, I have all these different things I can do. Maybe one alternative is simply to turn it into a programming problem. I'll let you specify what each thing should do. That'd be a small matter of programming, SMOP. So that's always an architectural choice. It seemed attractive when this idea was first proposed by a bunch of guys down at Yale. They started a company, they were going to take the world by storm, and now you've never heard of them. So that sort of tells you what happens when bad things happen to good ideas. Or they turned out not to be, economically viable. This just wasn't enough of a win. So.